This is the fourth in a series of videos on confidence intervals, and this one we're going to focus on the issue of how do you know if your confidence interval is valid. So let's review real quickly what we mean by confidence interval. You might, for example, try to estimate what proportion of people get well from the flu in less than 3 days if they take a certain pill. And you get a point estimate of, say, 23% of your flu victims get well very quickly. But that's just a point estimate, so you might say, well, I'm actually 90% sure that the true number should be between 21% and 25%. That's the idea of a confidence interval. It has two elements to it. It has a range of numbers and a degree of confidence. But once we get this range of numbers, we might ask the question, is that a valid result? And that depends on a couple of things, a couple of questions that you need to answer. And the first question you need to answer has to do with randomness. That is your sample drawn from the population in a random way? And to the extent that the answer is yes, then you should be able to believe your confidence interval, and to the extent that answer is no, you should not. The second question you should ask if you're asking about the validity of your confidence interval is whether or not your estimator is distributed normal. And remember, there's simply some certain rules that we need to follow here. And if we're talking about means, sample means, the key is that n has to be large enough, and we generally say that n has to be greater than 28, 30, 32 or so. And the other possibility that we use a lot is what are called sample proportions. And for sample proportions, you have a somewhat similar one, but it has to do with n and p, and that is the sample size times the population proportion has to be greater than or equal to 10, and n times 1 minus p, that is the probability that the answer is false times the sample size has to be greater than or equal to 10 as well. And the third question we have is, are the members of your sample independent? And the key there is that if you get one large value for a sample, a member of your sample, does that not affect whether or not other people in your sample have a large number, or does it? And you do want it to be independent. So if it is independent, and you have reason to believe your estimator is normally distributed, and if your sample is drawn at random from the population, you should be pretty confident your confidence interval is valid. Otherwise, you should not be.